Okay, so this is Miss Dykes. I'm going to do some density notes and information with you today. Now, I know you don't have a journal at home, but you might want to get a piece of paper and write some of these notes down just so you'll have them to look back at easily. They'll also be put into the digital notebook posted in Canvas. All right, so we're just going to kind of go through this together, and we are going to talk about density. Okay, so in 5th grade, you talked about density, but you talked mostly about in comparison to water. So you would say if something's more dense, it would sink. If it was less dense, it's going to float. Well, this year you actually have to calculate density and get an actual number answer for the density of objects. Okay, so in order to do density, there's two things you have to know. The first one that you have to know is you have to know mass. Okay, so mass is the amount of matter in an object. The amount of matter in an object. Now, for us to find mass, okay, we use a triple beam balance. Which you probably, the video might lag a little bit, I'm sorry. You use a triple beam balance, which I'm sure you probably used in 5th grade, okay? Okay, so the second thing that you have to note in order to find density of an object is you have to know volume. And this one's a little more complicated this year. So volume is the amount of space that matter occupies. So it's the amount of space something takes up. All right, and there's 3 different ways you may have to find volume. The first is if you have to find the volume of a liquid, such as water or oil or something that is a liquid. In order to find the volume of a liquid, you would use a graduated cylinder. You just put the liquid in there and see what level it comes up to. Okay? The second thing that we're going to find the volume of are what we are going to call regular objects. And I'll explain to you what that means. Okay? Regular objects are going to be things that you can have a formula for. Things that you use a formula for. Now, in 6th grade, the only thing you know a formula for is for a rectangular prism or a cube. Okay? And so you're going to use length times width times height to find that. When you get older, you will know some formulas for other shapes, such as a cylinder or a pyramid. But for now, the only thing you can find the volume of with a formula is a rectangular prism, which is length times width times height. Now, this year in 6th grade, you're actually going to change this formula to a capital BH, which stands for the area of the base times the height, but you'll learn a little bit about that in math class. Okay, so for regular objects, you would just do length times width times height. The third thing that we're going to have to find the volume of is what we're going to call irregular objects. Okay, irregular objects are going to be things that you cannot find using a formula. So such as a rock or a nail, something that has an odd shape that you don't have a formula for. All right, and so what we're going to use for the irregular objects is we are going to use water displacement. Water displacement. Okay, now water displacement is actually also known as, so AKA, also known as Archimedes' principle. And the name of that came from this old scientist named Archimedes, who lived in a time when there was not running water. You didn't have your bathrooms in your homes, and so he would go to take his baths in what was called a bathhouse. And those bathhouses were used a lot and weren't cleaned very well. And when he went to take his bath one day, he noticed that there was this ring around the bathtub, probably kind of gross, you know. And when he got in, that water rose and he couldn't see the ring around the bathtub anymore. And so he started questioning why that happened. And so what he figured out was that if you have a graduated cylinder and put a certain amount of water in that graduated cylinder, and then you drop an object in, that the water will rise the amount of volume that the object, you know, misplaced or displaced. Okay, so you would take like a graduated cylinder, let's say it was a rock, and if we had a rock, my camera's trying to die on us here. So if we had a rock, we could put like 50 milliliters of water in a graduated cylinder, and then we could drop the rock in, and if the water went up to like 60, you could say that it was a 10. And we'll practice this later. For now, we're just going to be writing the information down. But that's what water displacement is you see how much water something displaces. Now, the only thing with this is you can only do water displacement with things that are more dense than water. Because if you put something in the graduated cylinder that's just going to float on top, then it's not going to displace enough water for you to tell what the volume really is. Okay? All right, so once you have mass and volume, then you can calculate density. So density is how much mass, see there's that first word, how much mass is contained in a given volume. And there's that second word. I said you have to have mass and volume. So for us, we actually have a formula for density. And to help you remember the formula for density, we're going to write real big, I heart density. Okay? And I'm not just telling you that because I'm a science teacher. We're going to use that heart to help us remember the formula. Okay? So, if we draw this heart again, and we put a line in the middle, like a division line or a fraction bar, on the bottom, that kind of looks like a V. On the top, that kind of looks like an M, and I told you have to have mass and volume in order to do density. So what you're going to say is, that stands for an M, that stands for a V. M is mass, V is volume. So in order to find the density, you will divide the mass by the volume. Okay, so another way you could write this is you could write density equals mass divided by volume. And you talked about all the different ways to show division this year in 6th grade math. If we were going to put this into a division box, okay, remember the top number goes inside, so the mass would be inside of your division box. Okay, that would be the dividend. Your divisor, or the outside of the box, would be the volume. And then whatever your answer would be your density. Okay, so real quickly, I want to show you some examples of the triple beams and things that we're going to be looking at. Okay, so I've got this paper that we're going to do in our class, and it just shows the triple beam balance that you use to find mass, and it shows it has those little different riders. What you do is you put the weight on the end, whatever you're measuring, and then you're going to use these until it gets level at 0, and when you're done and it gets leveled, then you add up all the numbers off of the 3 riders. Okay, so it tells you here you add the large, the medium, and the small. Okay, the large is hundreds, the medium is tens, and the small is ones. So inside here, we've got this little paper. I'm going to zoom in on it. And so let's look at this one right here first. So what you would do is you would say, okay, well, there's 300 right here, there's 30 right there, and there's 9. So you would do 300 plus 30 plus 9, kind of like that old expanded notation you learned in elementary school. And your answer would be 339, and we use grams for our unit. Always put your unit. Okay, so that's not that bad. Now, it does get a little trickier if you start having decimal numbers, or it goes in between the whole numbers, and here's a good example here. You only will have that on this bar. So if you look at this one, that's a 0, so there's no hundreds. There's a 70, and now here's the one that's tricky. So look, this is a 6 and this is a 7, so we know it's going to be between 6 and 7, so we're going to have a 10th place. So each little line, since there's 10 spaces, is a 10th. So it'll be 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 6.7. Okay, that's where that is. That would be a 6.7. So you add the 70 to the 6.7, and you get 76.7 grams. Well, we didn't have a hundreds place on that one. Okay? So I'm going to let you try one on your own. I'm going to tell you to pause the video. And let's scoot right here and let's do this one, the second one. This one right here that my finger's pointing at. Okay, pause your video real quick and see what answer you get. Okay, so hopefully you got 425, added those three to get 425. Okay, so that's a little practice on using a triple beam on paper. Okay. Then I said the second thing you have to know is how to find volume. So what is volume? And it tells you this on this paper. But we're looking at rectangular prisms because that's the only one you have a formula for. And you're going to do length times width times height, just like you've done in math class. Okay, so let's look at this problem right here. All right, so if you're going to work this out, the first thing you should always do is write your formula. Okay. Then plug in numbers. Now remember in 6th grade we've started using the little dots for multiplication instead of the timeses, so I'm going to start doing that. So we've got 6 times 8 times 4. Now remember, since you're multiplying all of these, it really doesn't matter what order you do them in. You just have to make sure you're getting one number from each side and you don't use the same number when you shouldn't. So then you're going to multiply. So 6 times 8 is 48. And then we need to do 48 times 4. So 48 times 4. 4 times 8 is 32. So put your 2, carry your 3. 4 times 4 is 16. Plus 3 is 19. So your answer is 192. Now let's talk about unit real fast. When you're doing volume, your unit is always going to have something extra on it. So we've got centimeters. And then we're going to have this little 3 exponential right there that stands for cubed. Okay, because we're multiplying 3 centimeters times each other. So you're going to have centimeter cubed. Okay? Alright, I want you to look at this one right here. I want you to pause the video and work it out and then see if your answer matches mine. So hopefully you did length times width times height. Okay, 7 times 10 times 3. Again, if you did it in a different order, it shouldn't matter. So I would do 70. 70 times 3, that is 210. So your answer should be 210 centimeters cubed. Okay? So whatever your unit is, you're always going to put that cubed if you're doing volume. Okay? So that's how you do volume of a rectangular prism. Alright, and then I'm going to show you this one real quick. Okay, I know this video is getting a little long. Alright, so right here, we're going to talk about how we find water displacement. So we've got these 2 cylinders here, and what you do is you start with a certain level of water. So like this one, they chose to start at 30. They have this rock, and they're going to drop the rock into that cylinder with 30 milliliters of water. When they did that, the water rose. Okay, so to find the volume of the rock, you take the volume that it ended, the 35, and you subtract the volume you started with, 30, and you get 5 milliliters. Okay, so you just take whatever water you started with. If you had started with 50, then it would have risen up and you would have used that. So with this one, we took 30, we dropped the rock in and went to 35. So we subtracted 35 minus 30 and 5 milliliters. Now these are a little hard to do on paper because it's sometimes hard to see those graduated cylinders. The other thing that you have to pay attention to when you do graduated cylinders is you always have to check what the lines mean. Figure out what the scale is and see if it's counting by ones or if it's counting by twos or if it's counting, you know, by whatever. Like this one on here is counting by ones, but sometimes they'll be counting by twos or fives. So you always have to pay attention and double check what each line means. Okay? So here, that is your little introduction to density, and we'll be practicing some more next class.